Now these problems are basically easy. So these all are dehydration of alcohol. So the first one is dehydration of alcohol H2SO4, or you can take KHSO4 heat. Now you can make a double bond this side. There is no possibility to make the double bond this side. So product you will have, I will go fast because things are easy this time. You have bromine here, and then you have C double bond C, and then you have CH3. You can always put the hydrogen CH you will have, and here also you will have CH. Now the next one, if this is a dehydrohalogenation, but this time its a base is OUT minus, so this is iodine I have, hydrogen I have, so I have to put a double bond here. So I have to remove H and I, so I will have CH2 double bond CH, and H is basically gone, so I will have simply C, and then this side OET, and this side also I will have OET. So this is the compound I will have. In this case, I will have again dehydrohalogenation. Hydrogen and bromine should be antiposition. That is the required for E2 elimination, and that is the case here we have. So I have something like this. Now after dehydrohalogenation, this double bond is in one plane. I will have CH3 in the plane of this one, and CH3 also is in the plane. Are you getting? I have to remove this one. Now in this case I cannot remove hydrogen from here. I basically does not have any hydrogen here, so I am forced to remove hydrogen from this side. So it is easy. So let us say this compound I have carbon, then I have CH3. So one side I can make one double bond CH2, and then I can put one CH3 this side. So this is easy one. Now let us say in this case I have to remove H2O and HSO4, so I have to remove H2O from here and a double bond here. And now the question says I have only one oxygen, so I have to have one oxygen. This means Cn also gets hydrolyzed. No, I have already one oxygen here, so Cn does not get hydrolyzed. This is an important point because that's why molecular formula of the compound is given. So what I have to do, I have to remove H2O from here, so I will have a 7 membered 6 membered ring, 2 6 membered ring we will have, and we have a double bond here, and Cn will remain as it is. So we will have Cn here, and that will remain as it is because I does not have to hydrolyze this one. You can check the molecular formula of the compound OCH3 you have. Now if you wish, you can check the molecular formula, how many carbon you have. So 10 plus 11 and plus 1 12 carbon, so 5 5 10 plus 1 11 plus 1 12 carbon. So molecular formula C12. Hydrogen how many you have? 3, and no hydrogen 4 5 6, and here also you have no hydrogen, 7 8 9. You have 9 hydrogen. Let me check again. So this is 1 2 3, and there is no hydrogen, no hydrogen, no hydrogen, 4 5 6, and 3 9. I am missing some hydrogen. Basically there is 2 hydrogen, that's why I'm not counting. 2 2 4 plus 1 5 6 7 8, and 3 11, and one more hydrogen I should have. So 2 hydrogen, 2 I have here, 1 sorry, here I have 1 2 2, and here I have 1 1 1, and here I have 3. Now let us count. 1 2 3 4 6 plus 2 8 plus 3 11. 11 hydrogen I have. So C12H11, and I have one oxygen. So always we can check the molecular formula. Now this one, this is again dehydration of alcohol. Now I have OH here, and this side I does not have any alpha hydrogen, so I have to remove alpha hydrogen from this side. So product will be C, and this side let me make the first double bond, and I have CH2COOH. So let us say this side I will have one double bond I have already made, so CH. So let us say put this one, this carbon, I have a carbon carbon, and then I have this side COOH, one COOH, because this CH2COH has been converted, and now I will have one CH2COH as it is. So this carbon will contain, one CH2. Okay, so what we can do is, let us write the same compound in the details, and then we'll write. So I have COH, and here I have COOH. Now here I have C, and hydrogen, and this carbon contains This carbon contains 2 CH2, so CH2COOH. Here also I have CH2COOH. So this is the compound I have. So if I remove double bond, if I make a hydrogen, remove hydrogen here, I can make a double bond here. So C double bond C, and this side I will have COOH, and this side as it is CH2COOH, and this side I will have a double bond and then one hydrogen and one COOH. So this is the final product I will have in this case. Now in this case, this is again removal of HCl. I can make a double bond here because you cannot have hydrogen this side, so I can have remove hydrogen here and HCl here. So if I do the same thing two times, if nothing is written, I can assume this is done in two times. So I will have a double bond here, I will have a double bond here because I have to remove chlorine, and here as it is I will have CH3. No change this place, you will have CH3. Now let us say the next one. In this case again, although even molecular complexity, so reactant is molecule is very complex, but it does not matter for dehydrohalogenation. I have to simply remove HBr, so I can remove HBr from here because this does not have any hydrogen. This does not have any hydrogen, so I have to remove from this side and this side. Are you getting or not? So simply I have to put a double bond here and I have to put a double bond here. So things are easy. Let us make this diagram. So only diagram is difficult, it look like difficult, but everything is easy. This side you have this carbon contains a basically acetyl group, so this is acetyl protection, and now it's a double bond this side, and this side you have a 5-membered ring again, and then you have a bromine, so you will have a double bond this side, and this group is basically protected. So this is the final product in this case you have. If you wish, you can make something like it's a better way. So let us take slightly lower so that it look like waiter. So if you make this one, it will look slightly 5-membered ring. Are you getting? Now this one again, this compound looks like slightly difficult, but what you have a 6-membered ring and one oxygen. So let us make this kind of diagram. So you have one oxygen and 6-membered ring, and this oxygen you have CH2OCH3. So this carbon contains CH2OCH3, and this carbon contains OCH3. This carbon contains OCH3. This carbon also contains OCH3, and here you have bromine. Now things are easy. You have to do dehydrohalogenation. You have hydrogen, you have bromine. So you do dehydrohalogenation. So if you do dehydrohalogenation, product are easy to write. You have to make a double bond here, and things are easy. Just copy paste OCH3, OCH3 here. You have OCH3. Let us write OMe, and there you have CH2O CH3. Are you getting? Now let us say the next one. This is again case of dehydrohalogenation. You can remove HCl. So you have hydrogen. Either you can form double bond this side or this side. Both are the same thing. Are you getting or not? So you can make double bond this side. And here you have CH3. And this will remain as it is. Whatever. The configuration of this carbon will not change. So CMe3 is going out. So it will go out. And now hydrogen is going in, so it will remain as it is. Configuration in this case will not change. Configuration will not change. That is important. So configuration will not change.